So we're asked to evaluate the region R3 about the line y equals 3, and we have the x-axis here and the y-axis here, so this point here is the origin. So let's take a look at this. So we have our curve here, x equals 4y, and the x-axis, and the line x equals 8. So we're looking to revolve this region around the line y equals 3. So we need to add in that line. So the y equals 3 is going to be above here where y equals 2. So we'll put in that line. So there's y equals 3. So essentially what's happening now is this region is getting revolved around that line there. So what we want to look at are the large and the small radius to be able to set up our definite integral to calculate this. The large radius, if we can see our rotation there, it's going to go from the line y equals 3 down to the x-axis. Now notice no matter where I put that line, it's always the same. So our large radius is a constant value, call it capital R, and it's always 3. Now our small radius we can see is changing because it's from this line x equals 4y up to the line y equals 3. Now we know that the whole thing from the line to the x-axis is 3. What we're looking for our small radius is this red line here. So we need to basically subtract out our function away from 3. The only problem is right now our function is solved as a function of y. We actually want it as a function of x. So we'll find the inverse of our function here. So y equals x over 4. And that's going to be what we use to find our little radius. Let's call it little r. We know the whole distance is 3. We're subtracting off 4y. That will give us this remaining distance here, the radius from our curve, between our curve and our axis of rotation. So 3 minus x over 4 is our little radius. This gives us the information we need to set up our integral. So we start our integral. Don't forget it needs pi. I like to multiply mine on the outside. We got our big radius, which is 3, and it gets squared, minus our little radius, 3 minus x over 4, which also gets squared. This is getting done in terms of x, because we've got a horizontal axis. The only other thing we need are our limits. We can see that our region goes from x equals 0 out to x equals 8. So those will give us our two limits.